So yeah, nice to see you all. My first talk, and I've been working on this one problem. It's been nagging me like for a while in JavaScript, and I've kind of figured out ways around it, and it's helped me. I thought I'll share with everybody else and watch them break it apart. So here I am. So let's get started with what I'm going to talk about. The big JavaScript debate of testing stuff that you can't reach, right? The private functions in general. These are the express handlers, anonymous functions, which you can't really reach, and therefore you do all kinds of mocks, and there are a lot of libraries, a lot of documentation you have to read, and super hard for newcomers in general. I'm going to talk about things to think about. These are not my opinions, these are just my observations. I want you guys to also think about it and talk to me about it. And then things that I used to find hard, now it's a little easier. I'm going to talk about that. And then by show of hands, who has written unit tests in JavaScript so far here? Yeah, who loves it? Okay, all right. And who's written unit tests for other people's code? Who's written unit tests for other people's code? You guys love that? Okay, so now we know where the liars are. Now we know where the other liars are. Nobody right? Other people's code, yeah, it's always been super hard for me. And especially with GPT-4 spitting out code, now nobody talks about test-driven development anymore, right? The code's already there. When am I going to write the test? So let's kick it off with something fun, right? It's got to be a Bollywood movie, straight up. I want you guys to watch this scene from this movie. Keep that in your mind, and maybe you will use it later. It's in Hindi, by the way. You don't have to understand it. Okay, why did I show that? You guys will know later. Just keep that in mind. With that, let's talk about private functions. What is hard in JavaScript? Why is it so hard to mock stuff? In that video you just saw, I think of the golf club as the public function and the ball as something private. That's exactly what you want to test, and that's where the logic lies. The other thing is just the interface, right? And you saw what the guy did, just reached in, just went outside the rules, took the ball, put it in the hole, say it's done. I made sure that the ball goes in the hole. Instead, what I've been doing is trying to mock the club, trying to mock the golf course hard, right? And I'm not saying it's the right thing to do, but it's something to think about. So should I test private functions? You should call a function exactly how some client would use it, right? Don't do it the wrong way. How would somebody who's using the function, who's using the module, call it? Do that. That's what they say. That's why they say no. And they also say do not test the implementation. Just use the interface, call it. But then nobody tells you what an implementation is, right? Like what? And some people say yes. When I say some people, over here it just could be me. I say yes sometimes because the large file that's already in production is deemed to be okay. I got to make a change. That's this small in this small function. The code doesn't have tests. What am I going to do? I only want to test my part. I don't want to test the other stuff, right? I want to finish my story and submit it and keep the project going along, because the whole project might be completely worthless for the company anyways, right? So what do? Dependencies are hard to mark. That's another other problem. We just import a bunch of stuff in JavaScript code. And what happens is nobody knows what those imports do. right? Some of these things, set up database connections, start writing the files. You don't really know what it does. And side effects go wild with these dependencies. Have you guys felt all these things? Okay, good. All right. My conclusion is, do whatever you want. Right? I'm not going to tell you what to do, but if you do want to test private functions, it should be as easy as testing anything else, right? Do you agree? Maybe you will at the end of the talk. Let's see. All right. So this is a lame diagram I made on the train coming here. This is the implementation part, right? The browser is your web app. It's called an interface because it's a user interface. And then it uses HTTP, talk to the server to get stuff done. And you could write your tests there, call it API testing. And in the browser, you'll call it UI testing. Or you could say, I don't want to talk about APIs. Let's just talk about the modules that make the API work. Let's just focus on those. Let's write more tests there. But then there's another end to it, which is the functions, which are inside the module itself, right? So you could go in that direction. And this is a decision that all of us make in the org. It's faster, cheaper. You get better coverage if you go this way, but it's very brittle. The first change that comes along, things break. And this way, like the other tests that you saw, you can't run those tests in under half a second, ever, right? So it's slow, expensive, because it kind of relates to an environment somehow. And now you're setting up Docker images and this and that. Costs money, coverage issues. Yes, the website kind of works, but is all the code executed? You don't know, right? But however, it's robust. More changes come in, chances are it won't break as much because the basic functionality kind of works, right? And you throw AI in this mix, you don't know which way to go now. What is AI good at? If I went that way, would AI do a better job? Or would having this way, would have AI done a better job? AI is really good at writing text. So I'm thinking you should go this way. Okay, again, giving you more knowledge on private functions and stuff. This is like, this is AI generated, by the way. So this is kind of like a public-private thing. Basically, you have a mechanic and you say, I have some expectations from the car, but you can't touch any other part of the car. You can only use the steering wheel and the gas pedal and the brakes. But you got to make my car work wonderfully well, right? Mechanic's not going to like it. He's going to go under the car, figure out things. So this is what we do, writing tests. We mock stuff. We lift the whole code up. We put it in an environment where you can test things. And this is how it looks right now. But what if you could make it like this? You make the entire car explode, and you walk around every part. You pick what you want to do. And nobody's laying down the rules saying, you can't touch that engine. No, if I want to explode the engine, I'll explode that too. You can't tell me what to do. You pick the part that you think is a problem, test it, because isolation is super important, right? Unfortunately, when people write code, they don't usually think about these things, including me. So, okay, all right, that's where the presentation stops. So let's start talking about how I went about doing things. Is that font size okay?
Not yet. Bigger. Almost. There you go.
I'm not going to make any sense of these things. Let's see. Okay, all right, let me just show you how. Okay, one other quick thing I want to point out is everybody in the crowd knows like what an AST is. It's an abstract syntax tree of the code. So when you write code like that, it gets converted to this. So in that car example that I gave, where you explode things, one way, so for that example, in this example, if I did not export the sum function in this file, how can I test the sum function? One way to do it is to make the tree parse the tree as if it was a DOM tree, pick the sum function, which is somewhere here. There's an identifier, arrow function expression, and that's the code, right? If you go that far, and then you pull out that node, and then you generate code again, you get a pristine sum function, which you can test. And everything for that sum function, there are no globals, no closures, nothing. Everything is a global. So if you run it in a separate environment, giving it whatever globals you want to supply, it's going to be tested. Because my only concern is the logic inside the function, because that's the part I wrote, right? This is the approach. Are you guys freaking out yet? No? Okay. I didn't warn you enough, like stuff you probably haven't seen before. It's the first time I'm showing to people. Okay, here we go. Same function again. There's this logger dependency. As soon as the test imports this demo1.js, that log is going to be imported. The log is going to be imported. And that thing is going to do stuff, right? It might be dependent on Node.js libraries, front-end browser libraries. You don't know, right? So you don't even know whether this function can be tested on the browser or not because of that dependency, right? So this is how a test would look for that. Typically, no, not that's the solve. Let's talk about the test itself. This is what ChatGPT gave me. Globals, importing the thing, demo, expect sum 1 to be 3, works well. But yeah, we're importing the log module, which is not needed for this test at all. And if I run the coverage, this is something strange that happens as well. You see, oh, how do I make it so that it, yeah. It picked up coverage for logger as well. It says logger is now covered 66%. I was not even testing it. Why did that come in? Because it was imported in the test. And therefore, it picks up the coverage for that one as well. That's how we were living. How do you, my hack around it is what I explained to you guys earlier. Shameless plug on the utility that I wrote. It's called mainEffect.js. Basically, it's a utility that helps you avoid side effects. It's just focus on the main effect, right? And what it does is demo1 file. In the other file, we kind of imported it, but here we don't import it. We get the absolute path by saying require resolve. And then we parse the file. And then in that, why am I pointing there? I should just do this. Sum is the same as, it's an AST parsed version of the same file. In that, I say find sum function, which is how I parse down the AST or go down the AST. And then I say, if I call the function right away, it's going to complain about log, right? So I'll say provide a log, which is this, empty. And then call it with 1 and 2. And expect the result to be 3. And in this, there's no logger module being imported. It can run on the browser. It doesn't matter. It's pure JavaScript. And when I run this, only demo1.js is picked up. There's no log or nothing. So you only test what you want to test. Okay. Good so far?
Yeah.
Right. How am I doing on time? Okay, cool. As long as these people don't walk away, I guess I can keep on doing it.
So
Right.
that's where we're at.
Cool. Okay, let's do the next one here. I can maybe share this code later with you guys, but then here's another function. In this, there's a handler and an async here. It also, and then there's a request and HTTPS there. So in this, I'm going to show you a regular test. Let's not talk about the regular test. Let's talk about how I would be doing it in the mainEffect.js. Again, I resolve it. And if there are any top-level functions that run right away, those are really bad. Generally, when you write modules, make sure you don't make things run automatically. Export something and let the caller makes anything happen. Like typically in an Express first app.js or whatever index.js you have, you start saying const app equal to Express. Don't do that. Like wrap it in a function, export it so that somebody else can call it, right? So if you want to, in this case, I have a demo 2. That's this guy. Yeah. So request is here. So I can, while I'm resolving it, I can also say, here's request, and whenever request is called, just return John. Again, I find handler, and I provide log. Inject is another alias for provide. Instead of calling the actual math function, I'm just saying, and random is called, just return 1. And then I check if the point of this was to show stubs. Your JSON stubs still work. So in this provision and injection, you can actually give stubs to it and then assert on the stubs. Same stuff, whatever you've been doing before, right? And that works as well. And this is the last piece of code I want to share. Now this guy. Have you guys encountered stuff like this, where there's logger.stream.foo.bar.info? It's like this chain of stuff that you have to mock. You have to make an object inside an object and the key and an object and finally something. And then there's weird shit like this, like logger. Sometimes it's object's a function now. It's logger.this.info, which info is now a function. And then it does something like that. What you can do with main effect, because we are doing AST parsing, you do something like this. Stub logger.stream.foo.bar.info. It understands that info is a function because you made it that. So it'll automatically stub it for you in one line. Okay, let's get to the fun part.
Where is this main effect library?
It's open source on GitHub.
GitHub.
Yeah, wow. Cool. All right. Now I did say something about GPT. I did not say that just to get eyeballs. I was like, okay, let's make this a little more sexier. Like, what do you do, right? Let's make people not going to install my npm module. They don't even know my name. They're not going to do this. I was like, maybe I'll throw it on the web. So this is that. In here, if everything goes okay, I'm going to be able to do the same testing on the web. So every function is, you get a little code lens. They call it code lens in VS Code. A little assistant on top say test this function. When you tap on that, it automatically draws the coverage in front on the top, and then you can inject what you want. In this case, A and B are being called. If A is greater than 10, foo is called, right? So let us give it some. A should be greater than 10. So let's give it 11, and let's say 10. Command enter. Oh, log is not defined. This is because it needs something called log. So let's give it log. Now foo is not defined because it went past log this time. It's gone to A, so the lines move a little bit. Your lizard brain is focusing now because things are moving. And parameters, foo is not defined. Okay, let's give it foo then. Further, so you could basically test any file like this. And however large the file, there's another trick I'll show you guys. Let us say this particular, oh yeah, one more important thing. Every stub that you mentioned here, this is the syntax. It's a stub of log. And you can say log whatever you want here. And you'll see what that stub was called with over here. The guts of what happened to the stub. I've never been able to do this before. Like when you stub a few functions in a test and look like, okay, what did that guy get called with? Then you have to say expect this or console log stuff. You can just look at all these things in one shot. You can see that the logger was called with some, 11, and 10. And you see foo was called with nothing, right? And you can write a description saying should whatever and save this test. It's saved. And then you can look at the test file. Basically, Every test file written like in this format will have these parts. It will require the file. In this case, there's no file name, so I call it fake.js. Should return 3 and 2. That's the text I typed. And then there's a stub factory. There are a bunch of provisions you give, which is basically the stuff that you need to inject. Params, result error, try on that and call it with the params, and expect to match the snapshot. And that's it. With me so far?
Yeah.
Go. Where's the AI? I'm teaching you. I might be teaching you very bad things here. I'm not even teaching. I'm telling you very bad things here, but I don't even know. It's good or bad. Okay, let's get AI on this thing. Oh. I'm going to switch from manual mode to AI mode. What? No, hold on. Too soon. That was my gasping moment, dude. I told you to capture it. Okay, here we go. Pick a function first. And I say suggest tests. So turns out AI is really good when you give it small pieces of code. If you give it large files, it sucks. And this fits right in because you can go into the code and pick the smallest piece and give it to AI, and you can compose a bigger test file. So here are the suggestions you gave out. This is not me. This is AI. 1 tap, 2 taps, 3 taps, 4. Covered. Show the test file. Take it where you want to. Cool? It is cool. All right. Now the other oops incident. Let's go there. I started with at the beginning saying testing is boring, right? It has to be boring. It has to be dumb. There should be no utils, no logics, no nothing, no data, no inheritance, nothing. You should be give this, get that. However long the data, do it. It's just simple that way, right? Easy to understand. So now, instead of, did I refresh the page? Yeah, no, I didn't save this, okay. What if we can make it as cool as a Candy Crush game? Right? If you look at this, each diamond is a statement that you need to capture. And I could imagine, I was actually thinking of doing this cool thing, but I'm not smart enough, where I could put this up on the screen and let all of you write unit tests for me. All of you will try to cover and capture one of these diamonds, and you get incentivized somehow, right? You could do that because all you're supplying is tidbits of code. Now let's ask it to suggest tests again.
Does it give you the same tests every time?
Yeah, it's just gimmickry here. It's the same stuff. It's just the coverage report represented differently. There goes the first two. That one, that one, that one. We're covered. Capture the flag. And same test file again. That's pretty much it. That's my talk. Thank you.